Welcome to lesson 82 of our interactive notes. Today we are identifying a line of symmetry, pages 39 and 40. All right, we have our content objective here. Let me get this moved over a little bit. There we go. So our content objective for 4th grade Geometry 3. I can recognize and draw lines of symmetry. Language objective. I can use vocabulary related to geometry to identify lines of symmetry. Social objective, I can work with others to use models and help prove lines of symmetry. So first, what is a line of symmetry? Line of symmetry, reflection. One half is the same as the other half. Folding on its imaginary line matches each side exactly. So here, there's a picture of a butterfly that if this were paper and you folded it perfectly on this line, every side matches up to the other. It's a mirror image or a reflection across that line. So this would be a line of symmetry. Here we have a dragonfly. Same thing across this line. If you were to fold it over, each point matches on the other side. It's a perfect reflection on the other side. We may be using lines called diagonals. So a diagonal is a straight line joining two opposite corners of a square, rectangle, or other straight-sided shape. So for any polygon from one vertex to the other vertex that is across the shape on an opposite side is a diagonal. So we are going to need a straight edge of some sort. I'm going to use this. You could have a ruler, you could have the side of a folder, side of anything that has a straight edge to it, just to make it a little easier. Alright, so it's hard to see, but this word says symmetry. S-Y-M-M-E-T-R-Y. Symmetry is when one shape becomes exactly like the other when you flip, slide, or turn it. So we are just looking at the flip or the reflection. So a square, a perfect square has 4 lines of symmetry. We have one that's vertical. If you can't see it very well, you could draw it in. We have one that's horizontal, and both diagonals. On an equilateral triangle, we have 3 lines of symmetry. We have a vertical one, and then from each of the vertices. Because if you turn this equilateral triangle around, you could see that it actually looks exactly the same orientation as the beginning one. It also has what's called rotational symmetry, but that's for a different grade. This one has 2 lines of symmetry, one that's horizontal and one that's vertical. So those were already on there, they were just a little bit light. This one, the diagonals don't work because these sides aren't equal, so they don't reflect or flip over it as easily. Okay, the lines are missing also. So there was a line right here to show, and this one means that this shape has 1 line of symmetry. The dashed line is a line of symmetry. If the heart was folded in half, both halves would be exactly the same size. So this is where that line of symmetry is, and that's what that one has to do with. This one, it should be a square, but it's a little bit more squashed. So it should have 1, 2, 3, supposed to be a square, so it has 4 lines of symmetry. Figures can have more than one line of symmetry. Lines of symmetry pass through the center point of a figure. So if you notice, they all cross in that center point. Same as up here, we have them crossing at a center point for those shapes. And then here, like the scalene triangle, some figures have no lines of symmetry. You have to have some sides that are equal or congruent to be able to get a line of symmetry. Okay, so let's look down at these shapes. So here we have a shamrock or a clover, and just to make it a little easier, use my straight edge. And if I were to fold on this vertical line, now my line's not perfect, that's okay, but if I were to fold on this vertical line, each point would match up with the other side. It's a perfect reflection on the other side. So does this have, is it line symmetric? Does it have a line of symmetry? Yes. Number of lines of symmetry. Well, so far I have 1. If I were to draw another one right here, would that perfectly reflect over to this side? Do we have a curve on this side here? No. If I were to do the diagonals, would this reflect perfectly over here? No. So it looks like we only have 1 line of symmetry. Now let's look at this one. So I can draw that vertical one. Oops. So here it can fold perfectly over that line of symmetry. It's a perfect reflection. So is it line symmetric? Yes. Number of lines of symmetry. Well, let's see. If I take this star, which actually has 10 sides, so it's a decagon, and turn it this way, it looks just like the one I just drew a line of symmetry on. The orientation's now the same. Okay, so there's at least 2. If I turn it again, it now has the same look as my first one. So it also has what's called rotational symmetry. Okay, and then if I turn it again, it looks exactly the same as my original. So far I have 1, 2, 3, 4 lines of symmetry. I could turn it one last time. It's hard for me to show you there, so I could keep turning it and you could turn yours. But I have one last one that goes from a point on the outside to a point on the inside. These would be diagonals of sorts. Oops, that one was a little off. This is a reason why it's important to use pencil when doing math instead of pen. Unfortunately, on the camera it doesn't show very well. Anyway, so here if you notice they all cross in that center point. That's the very center of the shape. So we ended up with 1, 2, 3, 4, 5 lines of symmetry. So now we're going to look at these shapes up here. And we're going to see, does it have a line of symmetry? Yes. Because I could make a vertical line that it could fold over or reflect across perfectly. Number of lines of symmetry, 1. Because any other one I draw, a horizontal line, diagonals, it won't reflect across perfectly. Does this have a line of symmetry? Let's see. I have a horizontal line, vertical line there, not horizontal, vertical line here that it could fold across perfectly, reflect across. So yes. How many lines? Well, let's see. I drew a vertical one. Could I do a horizontal one? Could I fold across that horizontal line? Mine's a little bit off. But if you drew it in the right place, it should reflect perfectly across the horizontal. What about diagonals? No, those wouldn't reflect across perfectly, so we have 2. And then the last one just says draw them, which we already did. Hey, how about this? X. We do have at least one line of symmetry that it will perfectly reflect across. So does it have line symmetry? Yes. Or is it line symmetric? Yes. Let's try horizontally. Yes, it does have one there. What about on the diagonal? Would it perfectly fold across this line from here to here, from here to here to here to here? Yes. And that actually means also on the other diagonal. Sorry, took me a few times to get it actually where it should be. Again, a reason to use pencil. So it looks like I have 1, 2, 3, 4 lines of symmetry. Okay, and then here we have a crescent. It does not have a vertical line of symmetry, but it does have a horizontal line of symmetry. If I were to fold on this, every point matches up or reflects to the other side. So I have a horizontal. I already said vertical won't work, diagonals won't work, so it only has one line of symmetry. So what we need to do on these shapes is draw any lines of symmetry that we may have. So on this Pac-Man shape, we have one that we can fold across. On this plus sign, you have 1, 2, 3, 4. Just like our X, it's just turned. Okay. A pencil has a line of symmetry. A magnifying glass has a line of symmetry. This star is like the other star we did. It has 5 lines of symmetry, so we need to get all those down. So that one has 5 lines of symmetry from each of these vertices on the outside to an inside one or a concave one. And H has 2 lines of symmetry. A circle actually has an infinite amount, but because of this slash, it's now changed it. So it only has 1 line of symmetry that it would fold across. Okay. Now let's look at our lines of symmetry in our alphabet. A has a line of symmetry. B has a line of symmetry. As does C and D. So all of those have a horizontal line of symmetry. Q does not, R does not, S does not. E does. F does not, G does not, H does. H has 2 lines of symmetry. T does. Oops. U does. V does. I has 2 lines of symmetry. Oops, that's too far down. J has none. K has none. L has none. W has 1. X has 2. M has 1. N has none. Has rotational. S, N, and Z all have rotational symmetry. O, if it's a perfect circle, has an infinite amount. We can't draw that many, but just as many as you can. If it's an oval, it just has 2. But since this is more of a circle, you could draw a bunch in there. We'll put the symbol for an infinity. If it's a circle, it has an infinite amount, as many as you could draw. We won't take all the time to draw them all. If it's an oval, it only has 2. P has none. Y has 1. And Z has none. It has rotational. All right, let's go ahead and go into our 3 column notes and look more at lines of symmetry.